These are the lesson activities for section 5.9. Used to be 4.9 if you're using an older edition of the textbook. Okay, so we want to find the steady state vector for this matrix M. Hint, solve M minus the identity times Q equals 0. We would solve that for Q. Q is the steady state vector. Okay, so the reason for that is that steady state means we're looking for a vector Q so that M times Q gives you Q back. And then to solve this, we subtract Q from both sides. You factor out a Q and you end up with M minus the identity times Q equals 0. Okay, so I'm going to take my matrix M and subtract the identity, which is 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, so M minus I. So 0.95 minus 1 is negative 0.05. And then my next two entries in that row will be the same. They don't change because I'm subtracting 0. And then 0.03. Okay, 0.9 minus 1 is negative 0.1. And then again, 0.9 minus 1 is negative 0.1. And I'm going to augment with 0, 0, 0 so I can solve. Row reduce. So when I row reduce this, it looks like a crazy, terrible answer in my calculator. But if you do this little trick where you hit math, enter, enter, which changes everything to fractions, it's much nicer. So this is going to come out to 1, 0, 0, 0, 1, 0, negative 15 over 11, negative 10 over 11, 0, and 0, 0, 0. So I have a free variable, which means there are infinitely many solutions to this equation. The thing about a steady state vector, though, is that the entries, it has to be a probability vector. So the entries have to add up to 1. So let's write down what I've got here. This says Q1 has to be 15 elevenths times Q3. And Q2 has to be 10 elevenths times Q3. So Q3 is free. I would make Q3 11. Let's get rid of these fractions. And I would say one possible vector for Q would be Q1, Q2, Q3. So you choose Q3 because it's free, and I'm going to choose 11. That makes Q2 10 and Q1 15. However, that is not a probability vector, right? 15 plus 10 plus 11 is not 1. So I want any scaled version of this Q is also a solution because Q3 is free, right? So I'm going to add up the entries of 15, 10, and 11, and you get 36. And I'm going to divide every entry by 36. So my actual steady state vector is going to be 15 over 36, 10 over 36, and 11 over 36. Okay, next problem. Rent-A-Lemon has 3 locations from which to rent a car for one day: the airport, downtown, and the valley. Of all cars rented from the airport, 95% are returned to the airport, 3% to downtown, and 2% to the valley. Okay, so we're getting a bunch of information here. We're going to put it into a stochastic matrix, which is the first part of the question. Give a stochastic matrix to describe the situation. So we're going to call it M for matrix. And I have from, where I'm renting from, and where I'm returning to. Okay. So let's see. I have Airport, downtown, and valley. Airport, downtown, valley. Airport, downtown, valley. Of all the cars rented from the airport, 95% are returned to the airport. So from A to A, I put a 0.95 here. 3% are returned to downtown. So from the airport from A to D is 0.03. And 2% are returned to the valley. So from A to D, 0.02. Okay, of all cars rented from downtown, 90% are returned to downtown. So from D, 2D is 0.9. 2% to the airport. And 8% to the valley. And of all cars rented from the valley, 90% are returned to the valley. 5% to the airport. And 0.2 of the cars. Oh, sorry, I misread that. And 5% to downtown. Okay. Give the initial state vector. Is it a probability vector? So that's the last sentence. My initial state vector, which we often call Q0, is half the cars are at the airport. So we have to do the same: airport, downtown, valley. So half the cars are at the airport. 3/10 of the cars are downtown. And 2/10 are in the valley. Is it a probability vector? Yes. Because the entries add up to 1. All right, what percentage of cars will be at the airport tomorrow? So we're going to multiply our stochastic matrix times our initial state vector. So Q1 is tomorrow. Multiply that times the current state. And we'll get the number of cars tomorrow. So this comes out to 0.491, 0.295, 0.214. I just did it in my calculator to save a little time. You could do it by hand just as easily. Okay, what percentage of cars will be downtown the day after tomorrow? So that's Q2. So I'm just going to do Q2. I'm not going to rewrite that matrix, just call it M times Q1. Do this in my calculator. And you get 0.48305, 0.29093, and 0.22602. What percentage of cars will be in the valley 3 days from now? So that's Q3. Matrix M times Q2, which I just calculated. And that comes out to 0.476, 0.288, and 0.236. And I'm rounding because the decimals are starting to get a little bit unwieldy. And then find and interpret the steady state vector. So we did this, see part 1, question 1, we answered, we found the steady state vector. It was Q steady state. 15, 10, 11, each one out of 36. Okay, and that comes out to approximately, if I get decimals, 15 over 36 is 0.42. 10 over 36 is 0.28. And 11 over 36 is 0.31. If I didn't round them, they would add up to exactly 1. You know that from the fractions. So to interpret, this is airport, downtown, valley. So in the long run, after many days, there will be about 42% of cars at the airport, about 28% downtown, and about 31% in the valley. All right, next question. On any given day, a student is either healthy or ill. Of the students who are healthy today, 95% will be healthy tomorrow. And of the students who are ill today, 55% will still be ill tomorrow. Stochastic matrix for this situation. So I have from and to. So you could start healthy or ill, and you could become healthy or ill. So if you start healthy, there's a 95% chance you will be healthy tomorrow. So I'm going to put 0.95 healthy to healthy. But that means there's a 5% chance you'll be ill tomorrow. So I'm going to put a 0.05 here. And then if you're ill today, there's a 55% chance you'll still be ill tomorrow. Ill to ill is 0.55, which means ill to healthy is 0.45. Suppose 20% of the students are ill on Monday. What percentage of the students will be ill on Tuesday and on Wednesday? So the current state vector, Q0, we have to match the way we did the stochastic matrix. So it has to be healthy, ill. So we have 0.2 ill, so 0.8 healthy. So I'm just going to do Q1, which is Tuesday, Q1. That's the stochastic matrix times Q0, which will give me 0.85 times 0.85 and 0.15. 85% healthy, 15% ill. And then Wednesday, that would be Q2, the next day. Just do the stochastic matrix times Q1, which we just found. And we get 0.875, 0.125. And this is, again, healthy, ill, healthy, ill. All right, find and interpret the steady state vector. So we have to solve m minus I times q, which will be the steady state vector, equals 0. So m minus I, 0.95 minus 1 is negative 0.05. The 0.45 doesn't change, and neither does this 0.05. And then 0.55 minus 1 is negative 0.45. Augment with zeros and row reduce. We get 1, 0, negative 9, 0, 0, 0. This says Q1 minus 9 Q2 equals 0, which means Q1 equals 9 Q2. And I can pick any value for Q2 to be my because it's a free variable. So one solution, because I have a free variable, there are infinitely many. So I'm just going to find one. I'm going to let Q2 be 1. and that means Q1 would be 9. So I picked the free variable, calculated the Q1. That's not my steady state vector because it's not a probability vector. The entries have to add up to 1. So my Q steady state is the vector I just found, 9, 1, but I'm going to add the two entries together to get 10 and scale each entry by 1/10, divide each entry by 10. So I'm going to have 9 tenths, or 0.9, and 0.1. To interpret, this is healthy and ill. So over many days, or in the long run, about 90% are healthy and 10% ill. Okay, if a student is healthy today, what is the probability that he or she will be healthy 2 days from now? So if you're healthy today, that means your personal state vector is 1, 0, right? You are healthy, not ill. So for healthy, ill, for a given person, it's 1, 0. So I just need to do my stochastic matrix for tomorrow. So Q1, that's tomorrow. Do my M times 1, 0. This will be easy to do in my head, so maybe I'll write it out. Okay, so you get 0.95. That's my first row times 1, 0, and the second row times 1, 0 is 0.05. Okay, and then Q2 is M times Q1. Stochastic matrix times 0.95, 0.05. So this is the second day, 2 days from now. And that will come out to approximately, actually it comes out to exactly 0.925 and 0.075. So if a student is healthy today, the probability that he or she will be healthy 2 days from now is 92.5%.